Hello students, with me Miss Yessica. Since last week we have learned about hemoglobin, so today we are going to learn about heart. The heart of an adult human has a mass of around 300 grams and is about the size of your fist. It is a bag made of the muscles and filled with the blood. Talking about the locations of the heart is located in the thoracic cavity, posterior to the sternum, superior to the diaphragm, and between the lungs. The tip of the heart is called the apex. Heart has 3 layers, 4 chambers, and 4 valves. The 3 layers include the pericardium, endocardium, myocardium. And the 4 chambers includes 2 atrium, 2 ventricles, and the 4 valves are mitral, aortic, tricuspid, and pulmonary. Heart function. The heart pumps oxygen, the nutrient-rich blood to the organs, tissues, and the cells of the body, and eliminates waste products. Besides that, blood is carried from the heart to the organs through the arteries, arterioles, and capillaries. Blood returns to the heart through the venules and the veins. Layers of the heart. First is the pericardium. The heart is surrounded by the fibrous sac called the pericardium. The functions of the pericardium is to limit the cardiac distensions and restrict the excessive movement, and to protect and lubricate. The pericardium is composed of visceral pericardium, parietal pericardium, pericardial cavity. Second is the endocardium. So endocardium is the innermost or the deepest layer of the heart, lines the heart chambers and the valves, smooth thin lining to reduce the frictions of the blood flow through the chambers. The cardiac conduction system is located in this layer. The third is the myocardium. It's the middle, the thickest layer of the heart. It contains the muscle fibers which are responsible for the pumping. The contractions of the layer allows the blood to be pumped through to the blood vessels. The chambers of the heart. So I have mentioned that the chambers of heart, they consist of 4 chambers. So the RA stands for the right atrium. RV stands for the right ventricle, LA stands for the left atrium, LV stands for the left ventricle. So there are a total of 4 chambers of the heart. Upper chambers of heart. So the upper chambers are the atrium. Okay, basically because they are located at the above part of the heart. So the atrium has 2 parts, which are the right atrium and the left atrium. So continue about the upper chambers of heart. The first that we are going to talk is the right atrium. So the right atrium, it receives the oxygenated blood from the body through the superior vena cava, head and upper body, and second through the inferior vena cava, legs, and the lower torso. The left atrium receives the oxygenated blood from the lungs through the pulmonary vein. Lower chambers of heart. So the lower chambers are the ventricles, which consists of the right ventricles and the left ventricles. The right ventricle receives the deoxygenated blood as the right atrium contracts. The left ventricle receives the oxygenated blood as the left atrium contracts. Valves of heart. Valves are located within the chambers of the heart. The function of the valves, first, to control the directions of the blood flow. Second, to allow one-way flow of blood, first through the chambers, second from the heart to the body. The 4 valves are known as, first, the tricuspid valve, second, the pulmonic or the pulmonary valve, third is the mitral valve, and the fourth, the last is the aortic valve. The tricuspid valve is an atrioventricular valve situated between the atria and the ventricle. It controls the opening between the right atrium and the right ventricle. The mitral valve is an atrioventricular valve situated between the atria and the ventricle, the same as the tricuspid valve, but it controls the blood between the left atrium and the left ventricle. The pulmonic or the pulmonary valve is a semilunar valve. It controls the blood leaving the heart. It's situated between the right ventricle and the pulmonary valve. It controls the flow of the blood from the right ventricle, and it also prevents the blood flow back to the right ventricle as it relaxes. The aortic valve is a semilunar valve which controls the blood leaving the heart. It controls the blood flow between the left atrium and the aorta. The cardiac cycle. The cardiac cycle is the sequence of events which makes up one heartbeat and consists of three stages, which are the atrial systole, ventricular systole, and the last one is the ventricular diastole. Atrial systole. The pressure developed by these contractions is not very great because the muscular walls of the atria are only thin, but it is enough to force the blood in the atria down through the atrioventricular valves into the ventricles. The blood from the atria does not go back into the pulmonary veins or vena cava because these have the semilunar valves to prevent the backflow. Ventricular systole. About 0.1 seconds after the atria contract, the ventricles contract. This is called as the ventricular systole. The thick muscular walls of the ventricles squeeze inwards on the blood, increasing its pressure and pushing it out of the heart. As soon as the pressure in the ventricles become greater than the pressures in the atria, this pressure differences pushes the atrioventricular valve shut, preventing the blood from going back into the atria. Instead, the blood rushes upwards into the aorta and the pulmonary artery, pushing open the semilunar valves in these vessels as it does so. Ventricular diastole. Ventricular systole lasts for about 0.3 seconds. The muscles then relaxes and the stage called the ventricular diastole begins. As the muscle relaxes, the pressure in the ventricles drops. The high pressure of blood, which has just been pushed into the arteries, will flow back into the ventricles, but for the presence of the semilunar valves, which snaps shut as the blood fills their cups. During diastole, as the wall of heart muscle relaxes, blood from the veins flows into the two atria. The blood is at a very low pressure, but the thin walls of the atria are easily distended, providing very little resistance to the blood flow. Some of the blood trickles downwards into the ventricles through the atrioventricular valves. The atrial muscles then contract to push the blood forcefully down into the ventricles, and the whole cycle begins again. The conducting systems. The cardiac conductions is the rate of the heart conducts electrical impulses. The electrical pulses determine the order in which the chambers contract, or we can call it as the heart rate. So the path of the impulses travel, there are two. The first one is the sinoatrial node, or we shorten it as the S.Si, also known as the pacemaker of the heart. So the sinoatrial node is located in the upper wall of the right atrium. They are made of the nodal tissues, both the muscles and the nervous tissues. Here, the electrical impulse begins. Second is the atrioventricular node, located between the atria and the ventricles of the heart. They are made of nodal tissue. The electrical impulse is carried from the S.Si node and the AV node is stimulated. The atrioventricular node delays impulses by approximately about 0.09 seconds. This delay in the cardiac pulse is extremely important. It ensures that the atria have ejected their blood into the ventricles first before the ventricles contract. The atrioventricular bundle branches are located between the atrium and the ventricles. Fiber branches into two bundles, left and right side of the heart. The electrical impulse travels from the AV node to the bundle branches after the atrium have contracted and emptied. The AV bundle branches then carry the impulses down the center of the heart to the left and right ventricles. The AV bundles start to divide further into the Purkinje fibers. The Purkinje fibers located at the end of the AV bundle branches at the base of the heart. The Purkinje fibers are responsible for the contractions of the ventricles. So here is the heart anatomy overview. Okay, you can see there is the pictures, the heart organs pictures on the slide, and you can look at there are some of the numbers. So the first is the edge of the aorta. Okay, number 1, edge of the aorta. 2, superior vena cava. 3, pulmonary artery. 4, pulmonary veins. 5, the right atrium. 6 is the tricuspid valve. 7, the right ventricle. 8, inferior vena cava. 9, pulmonary artery. 10, pulmonary veins. 11, left atrium. 12, mitral valve. 13, aortic valve. 14, left ventricle. And 15 is the descending aorta. I think that's all for today. Thank you for your attention and goodbye.